Hello world viewers, what's up? I hope all you are doing well and your neos and bios are also doing well. First of all, I convey my best regards and heartful thanks to all of you, those who are watching my videos regularly. Thanks you for watching all these kind of videos, right? Good morning to those who are watching me in the morning, good evening to those who are watching me in the evening, and good night to those who are watching me in the night. Okay, so in last video, I was discussing about the time dilation factor. Have you remembered it or not? Okay, if you have not remembered, go and watch that video first, right? So in that video I use a equation. I told you that I use Lorentz transformation equation, right? That is Lorentz transformation equation, and I told you that after this video completion I will definitely post the latter video, that is Lorentz transformation equation. So today we are going to derive the Lorentz transformation equation. Before that, we also there is a similar conception. I mean, Lorentz transformation equations is there. The Lorentz transformation equation, when apply, when the speed of light, when the equation we have to understand first before learning the Lorentz transformation equation. That is Galilean transformation equation. What is that? That is Galilean transformation equation. That is Galilean transformation equation. So before knowing it, we have to know what is Galilean transformation equation. For this we have to take two consideration. In the last stage, in time dilation factor, I consider two frame, that is S frame and the S dash frame. S frame is the stationary frame, that means it has no motion, right? And the S dash frame, that is in the motion, right? If you remember that I got the example that I am sitting there and Einstein come with the rocket, right? So I just remember that this is the S frame, this is the X axis, this is the Y axis, and this is the Z axis. If you remember, on that case also I discussing like this thing, X, Y and Z, and here the observer is O, let's say, right? And here there is also another frame, that is S dash frame going on this. This is the X dash, this is Y dash, and this is Z dash. I say that this is moving with the v velocity, this is moving with the v velocity along the x dash axis, along the x axis, right? So here, and there is an event happening here. Let's say there is an event happening here. There is a rocket is launching from upside. Okay, there is an event happening us, and here is the observer is O, and here is the O dash. Here I am sitting, right? Here Einstein is moving on a space. So Einstein is moving on a space. He is with me at the time when t is equal to 0. When t is equal to 0, O and O dash at a single point. But after time t, he moved from this to this position, from move to this position. Let's say this total is x, right? It is the x axis, and it shifted. Okay, it shifted. That means how much it shifted? It is the v. Okay, it is the v. That means in time t, he shifted. How much distance? The speed is equal to distance over time. That means distance is equal to speed multiplied by time. Speed is v and time is t. So he moved how much distance? That is vt distance. What is the distance? This is vt distance. Vt unit the distance is, right? So here the four equations actually. What are the four equations we have to got? We have to got what is x dash, what is y dash, what is z dash, what is t dash. These are the four equations. This is the Galilean transformation equation. That's the thing. Nothing here. We have to just identify what is x dash, what is y dash, what is z dash, what is t dash, right? So here, what are the consideration I take? In S frame means it is the stationary frame. Means stationary frame. What does it mean? Stationary frame. It is in rest, right? S dash frame means it is in motion. It is in inertial frame of reference. It is in motion. That is in v velocity. Along the x axis. Okay. Here the two are the inertial frame of reference. I told you what is the inertial frame of reference. When the body is moving in constant velocity or the object is in the rest, that's called with the inertial frame of reference. Both the two are inertial frame of reference. We all know it. Okay. So next state, what we say that what is x dash? What is the x dash? Right? And what is y dash? what is z dash, and what is t dash. These are the four equations we have to derive here, and it is called the Galilean transformation equation. So simple, right? What is Galilean transformation equation? What is x dash, what is y dash, what is z dash, what is t dash? So x dash, what happens here? X dash, let's say this is the x dash. Okay, this is the x dash. What is the x? X is the total. Actually, x is the total. It is actually assimilated on it. It is lies on it. X and x dash. We can say x dash is smaller than x. We can say it, right? X and x dash is overlapped each other. Okay, so x dash is equal to, we can say, total distance is x. Total distance is x minus vt will be happen. 5 minus vt. If we go to the simple mathematics scenario, this total is x and this total is x, and this person to this person is known as x dash. That means this person is x minus vt. X minus vt. This is the distance. Or we can say the velocity is negative here. Why? Why the velocity is negative here? Because here O and O dash. O, for O dash, it looks like he come outside from him. He come further from him. That means the it will be minus by, because he come further to it. Minus symbolize the direction. Here minus symbolize the direction. When you are going to the positive side, means you are going to the front side. When you are going to the back side, then it will be negative. The signs indicates your directions. Okay, so what happens here? Distance equal to vt. That means x dash is equal to x minus vt. X minus vt. Right? This is the first lesson. Let's say this is the first equation we can see. Okay, the second equation, y dash will be y. Why y dash will be y? Because the frame is moving along the x direction, along the x-axis direction, right? That means there is no relation between y dash and y. No direction, because it is not moving on that case. So there is no any kind of relation on that, right? So y dash will be y, no confusion. Z dash will be z, and t dash will be t. You say t dash will be t. How? You say that when the body is very close to the speed of the light, then t is variable. In the previous video I told you that time dilation happens when the object is moving in the velocity of light, closely the velocity of light. But here this scenario is not happening. Okay, here the speed is so much less, that is b, and b is not even comparable to c. That means it is coming under the classical mechanics. It is coming under the classical mechanics. That means Galilean transformation equations, these fours are the Galilean transformation equation. And why t dash and t is not? Because the speed is not comparable to c, because v is very less than c. And why 2 and 3? Because the frame is moving towards the x-axis. The frame is moving towards the x-axis. Frame moving towards the x-axis. That's why y dash is equal to y and z dash is equal to z. Right? In the next state, we will see Galilean inverse transformation equation. What is Galilean inverse transformation equation? It is nothing. It is nothing. Just you can symbolize the x dash as x as x dash, x dash as x, and x as x dash. It is the writing method I am saying. Actually, Galilean inverse transformation equation. What will be that? That will be x is equal to x dash plus vt. If we look it, the total is x, then what will be that? That x dash is this person and this will be vt. So x dash plus vt, that's equal to x. There is no confusion. If you look at the scenario, x dash is x and x is x dash. That's the change, right? That's the change. Nothing happening here, right? And the y is equal to y dash, z is equal to z dash, and t is equal to t dash. T dash here same. Here t is constant, absolute. When classical mechanics happen, when Newtonian mechanics happen, when Galilean mechanics happen, the time is not coming under the relative. It comes under absolute. So it has no any kind of relation. Even time is also a dimension. I am telling you about that. Before, in that video, I forgot about by saying that time is also a dimension. What is the dimension? Dimension means it has a positive side, it has a negative side also. X has a positive side, X has a negative side. Y has a positive side, Y has a negative side, like that. Time has a positive side, time has a negative side also. The positive side we call it the future, and the negative side we call it the past, and the current scenario we call it the present. Yes, there is future, we call it the positive side of the time. When it equal to negative, it is the past, right? So when time travel comes, it comes to the future travel and it comes to the past travel. But past travels is not very much complicated, but future travel, there is a possibility that we can achieve the future travel, right? So these are the scenarios. This is the Galilean inverse transformation equation. This is Galilean transformation equation. Okay, so here the Galilean transformation equation completed. In the next step, we are going to derive Lorentz transformation equation. We will see what is the basic difference between this. The things are very much similar, just simple things happen on that equations or Lorentz transformation equation is that the speed is closely to the speed of light. That's why the scenario changes on Lorentz transformation equation. So here Galilean transformation equation is this much. And the same scenarios happen in Lorentz transformation equation also. This is the Lorentz transformation equation. What we will see in this diagram or these kind of scenarios, the simple things. But what happens? What are the changes here? Here the V is very high. Here the V is very high. It means it is moving in very much high speed. That means the V is very close to C. It is about 80% or 85%. We can say V is about 85% of C. It is the 85% of C. V is equal to, let's say, 85% of C. Then what happens here? The two scenarios happen. Two scenarios that time will not be constant here, right? Time is not be constant here. Then the T dash formula will be different here, right? And the X dash formula will be different here. What are the difference? Here, what happens? The simple things happen here. S frame is also stationary and S dash frame is also moving in some velocity that is very much high, right? So it is not coming under classical mechanics, it's coming under special theory of relativity. Okay, so what happens here? Here the measurement happening in S frame, the measurement happening in S frame is linearly proportional that to S dash frame. Hence there will be a constant. That is K. The constant will be K. Why? Because the proportionality happening here, and to equal the proportionality we will take a constant. Let's say that is K. Okay. Why this kind of scenario is happening? Because it is moving in high speed. So what are the simple fluctuation between the Galilean transformation equation and the Lorentz transformation equation? That is simple things. You can see the first equation of Lorentz transformation equation is X dash is equal to K multiplied by X minus Vt. What does it mean? That means X dash is directly proportional to X minus Vt. Here the simple things happening. That is why there is K is the constant, because there is proportionality happening here. Okay, the proportionality happening here. So what are the responsibilities here? We have to find out what is K. This is our big factor here, and we have to find out T. We have to find out Y. We have to find out Z, because the event is happening here. For example, the rocket is on the start level. What is the scenario for the O dash and what is the scenario for O? What are its coordinates? What are the coordinates of it? That's the equations actually. That is the Galilean equation. That's the Lorentz transformation equation. What we are seeing? We are seeing just deriving the coordinates of that point. It has a point X, Y, Z, T, and X dash, Y dash, Z dash, and T dash. These are the two coordinates of a single point. According to S frame, this is the coordinates. According to S dash frame, this is the coordinate. Right? So what happens here? X dash is equal to K X minus Vt is the first equation. Right? Then we will go to the next steps as well. Then what is the inverse Lorentz transformation equation? This is the Lorentz transformation equation. Then what will be its inverse? Inverse will be when X dash, there will be only X. When there is X, then it will be X dash. Otherwise we can take it from this side, right? If you take it from this side, X is equal to K X dash plus vt, x dash plus vt. This is the scenario. This is the scenario between x dash and x. So here what happens, I have a small mistake when the Galilean transformation equation is happening. That is, when the inverse transformation equation, then x dash plus vt dash will be happen, right? X dash plus vt dash. That's why here also will be vt dash. Okay, let's say this is the equation 1 and this is the equation 2. So what we have to find? We have to find in the Lorentz transformation equation the 4 coordinates. That is, what is x dash, what is y dash, what is z dash, what is t dash. X dash will be this much, x dash will be this much, right? And y dash will be y. Why? Because there is no movement along y axis or z axis. That's why y dash will be y and z dash will be z. And t dash we have to find. That's why we have to find what is t dash by applying this equation on that. And we have to find at the end that is t dash, because t dash and t are not equal here. At that case, you can replace. You can say it is t dash to t, t to t dash in Galilean transformation equation. Why? Because here there is no matter, because t dash is equal to t. In classical mechanics, it's happening. That's why that mistake happening by me. It is actually not the mistake. Why? Because t dash equal to t. Because there is no any kind of difference between this and that at that time when Galilean transformation equation happening, because it's coming under the classical mechanics. So here we are going here to that we have to find what is t dash, because we have to find the 4 coordinates. The first one is x dash, y dash, z dash and t dash. X dash is already here, y dash is equal to y, z dash is equal to z. That means we have to find what is t dash. At the end we have to find what is k, because if we find k, then everything will be with us, and these are the Lorentz transformation equation. Okay, so let's see what happens in the next. So here let's say put the values of x dash in equation 2. Put, this is the equation 1, put the value of x dash in equation 2. Okay, and let's say we have to write here x dash is equal to k x minus vt is the first equation, then x is equal to k x dash plus vt dash is the second equation. Okay, I have write it. This is the second equation. So what I say, put the value of x dash in equation 2. So we have to put the value of x dash. X dash is equal to something. That means x is equal to k multiplied by x dash. What is x dash? Here, what is x dash? X dash is equal to k x minus vt, right? Plus vt dash, plus vt dash. Okay, so these are the equations. So what will happen? X is equal to k multiplied by kx minus kvt plus vt dash, right? So here if we go to this, then x upon k is equal to kx minus kvt plus vt dash, right? So what will happen in the next? We have to find what is? We have to find x upon k minus kx plus kvt. Okay, if we divide both sides by v, then it will be t dash is equal to x upon kv minus kx upon v plus vv will be cancelled out, then it will be kt here. That's equal to kt. Okay, if we take common as minus kx plus b, minus kx upon b, then what will be remain? This will be 1, this will be 1. I took common as this point, minus kx upon b. So this scenario will be minus, 1, then minus will be plus, then what will be 1 upon k square, 1 upon k square multiply by k square. When this much will multiply by k square, minus will be plus, and kk will be cancelled out. That means x upon kv. That's when this term we got from these 2 points we took the common kx upon b. Okay, this is the simple calculations happening here. That's t dash is equal to, we got t dash is equal to kt minus kx upon b, 1 minus k square. So let's say this is the equation 3. This is the equation 3. What are the other 2 equations we have? This is the equation 1, this is the equation 2, this is the equation 3. So these are the three equations. I just write it out. T dash is equal to kt minus kx upon v 1 minus k square. Okay, this is the equation 3. So these are the three equations we have, right? These are the three equations we have. I just erase this. So here I will use something different, that is the Einstein second postulate I will use. What is the Einstein second postulate? Einstein second postulate. What is the second postulate? Second postulate is the constancy of the speed of the light. Constancy, not consistency. This is constancy. That is, the speed of the light is constant in the all frames. Michelson-Morley experiment happens after the Galilean experiment. That's why Einstein also agrees on those points, and he gives two postulates. That first postulate is that all physical laws are same in all inertial frame of reference, and the second postulate is that constancy of the speed of the light. That whatever the value is that, but according to that c is constant. Okay, from applying that c is constant, what we get actually here, this is the frame, the same frame here. This is the same frame. This is the S frame. This is the x-axis. This is the y, and this is the z. And here also the same shifted after some time, after the speed, that is v. Okay, this is x dash, this is y dash, and this is z dash. This is the rocket is happening. The event is happening there. I say that. And what the observer ion. So Sudipta is sitting in the stationary frame, and Einstein is moving in the velocity v. Einstein here, it is your dash. Here Sudipta is there, here Einstein is there. So what I say, I just took a laser light. I took a laser light and point out that. I took a laser light, point out that on rocket. Then Einstein also, yeah, you are doing. I am not. No, I have also a laser light. I'll do it from rocket. I'll do it from the space. He also took the laser light. So what will be my distance to this point? Speed is equal to distance upon time. That means distance is equal to speed multiplied by time. So what is the speed here? Speed is the c. And what is the time? That is t. That means from object or the observer O, that is equal to ct. Okay, from this point to, let's say this is the point P. This distance is ct. That means x is equal to ct. What is the x dash? That's equal to, here also the speed is c, because constancy, because speed of the light is same in all the frames of reference, right? So here also this will be c, but the time will be t dash, because t and t dash are not equal here. Why? Because the speed of that object, the speed when happening in the dash frame is very close to the c. That means the t and t dash will not be same. Time dilation happens here. Okay, then ct and ct dash, we get x is equal to ct, and x dash is equal to ct dash. Okay, ct dash. So we have to replace this in the equations, that is in equation 1 and equation 2. If you replace x as ct and x dash as ct dash. Okay, so what will be the equation 1? Equation 1 will be, equation 1 is x dash is equal to something, x dash is equal to ct dash. So if we put these values in equation 1, then ct dash is equal to k multiplied by x will be ct minus bt. Let's say this is the equation 4. Let's say this is the equation 4. This is 3. Okay, this is 3. Then if we put the values of x and x dash in equation 2, what we have? X is equal will be ct is equal to k, x dash will be ct dash, that will be ct dash plus vt dash, that is equal to equation 5. So we got these scenarios, equation 4 and equation 5. We got 5 equations till now. What are the 5 equations? That is x dash is equal to something, x is equal to something, t dash is equal to something. Here we got this, here we got this. Okay, these are the 5 equations we got. All these things are done, but we have to find the value of x. If we find the value of x, then all the scenarios will be in front of our eyes. So we'll find the value of x, sorry, the value of k, and the value of k and the value of 1 upon k square. Okay, value of k, we have to just multiply the equation 4 and equation 5. We got the equation 4, we got the equation 5. To find the value of k, we have to just multiply equation 4 and equation 5. Let's see what we have. Then equation 4, multiplying happens left hand to left side and right hand to side. Left hand multiply by the left hand side, right hand side multiply by the right hand side. So what will the left hand side? That ct dash multiply by ct, that will equal to c square t dash, right? In the right hand side it will be k and this much and multiply by k this much. That means it will be k into k, that's equal to k square. Then it will be, if you took common as t, then t c minus b multiply by, if you common t dash to t dash, then it will be t dash c plus b, right? C plus b. Okay, so here you can clearly see t and t will be cancelled out. It is in the both side and it is in multiplication form, not in the plus form, not in the minus form. That means t will be cancelled out from the both side. T dash also cancel out from the both side. So what we have, that implies c square k square c minus b multiplied by c plus b. We all, what is that formula? C square minus b square, right? So we have to find out what is k square. What is k square? That means k square is equal to c square upon c square minus b square. Okay, so k square is equal to c square minus b square, right? Implies then k square is equal to, if we take c square common in the denominator side, what will be happen? C square will be common, then 1 minus b square upon c square. So c square and c square will be cancel out. That means it's equal to 1 by 1 minus b square upon c square. So this is equal to k square. We have to find k square, we have to find k, and also we have to find 1 upon k square. As in the equation 3, the t dash, we need 1 upon k square. We need 1 upon k square. That's why we need 1 upon k square. What is the value of 1 upon k square? We can see this 1 upon k square. 1 upon k square is equal to, it will be opposite. That means 1 minus b square upon c square. This is the 1 minus k square value. And what will be the k? K will be, k is equal to 1 by 1 minus b square upon c square root over, right? Here we can find the value of k and we also find the value of k square. Then it is very much easy to find what is x dash and what is the t dash. Just we have to put these values. Let's put these values in these areas, then we will find our required equation, our required Lorentz transformations equations. We'll find our required coordinates. Okay, so this is the, let's say this is the fifth equation. So recently we just find the value of 1 upon k square and k. So we have to just naming this equation as 6 and this is as 7. So apply the equation 6, apply equation 6 and 7 into equation what is equation 1 and equation 3. Equation 1 and equation 3. Why? Because we have to find what is x dash, we have to find what is t dash. As we know, others two will be same. Okay, so what will be the x dash? According to this, x dash is equal to k multiplied by x minus bt. So this is the first equation we have. So we have a value of k here. So what will be the k? That means x dash is equal to x minus bt upon what will be that? Multiply. That means 1 minus b square upon c square root over, right? So this is we find what is x dash. Have you feel the happiness here? We are doing those kind of things to find this much. And another we will find also t dash. In equation 3 we just have to put it. So in equation 3, if we put t dash is equal to, what is the k? K is 1 upon v square minus 1 minus v square upon c square root over, that means t upon 1 minus v square upon c square root over. Okay, if we took k as common, it will be very much simpler to us. If we took k as common, then k in whole t minus x upon b 1 minus 1 upon k square. Okay, so here we can apply here what we can apply. So k, so it will be upon 1 minus b square upon c square root over, as it is this much. K is equal to 1 upon, so it is multiplied by this, that means 1 upon this upon this. Okay, so t minus x upon b, it will be 1 minus, don't forget that 1 minus is there. So what is the value of 1 by k square? That is equal to, look at this is 1 minus b square upon c square. 1 minus b square upon c square, that means what is 1 upon k square? 1 minus will be plus b square upon c square. Okay, so this is the value of t dash. So we have to find 1 will be cancel out. Okay, so what is this? That is equal to t dash is equal to t minus 1 will be cancel out, that means b1 will be cancel out, that means t minus xb upon c square upon 1 minus b square upon c square root over. Look at time dilation formula. I use Lorentz transformation equation. This is the fourth equation of this, right? Let's say this is the third equation of that, or what I say, it is the fourth equation, third equation, or what do you say? I just use that equation on that case, if you remember that, right? So this is the scenario. We just have to find the coordinates, right? We have to find the coordinates. What are the coordinates? Okay, so never forget about what is happening with y dash and z dash. We will see it. What happens with the y dash and z dash? It is moving on the x-axis, x direction. That is no with the y dash and the z dash relation. That means what happens here also, that y dash will be y and z dash will be z. So these are the four coordinates. This is the x dash, this is the t dash, this is the y dash, this is the z dash. Okay, we find all these kind of scenarios. So why here t and t dash is not equal? You find it out because it is moving on the very high speed. But what happens in the Galilean transformation equation? What is the meaning of transformation? Transformation is about to change. Transformation is about to change. I am something on that day, today I am something in this day. Okay, so when it comes to the relativity, actually for relativity it looks black to you, right? It looks the size looks like this. Okay, the size looks like cylindrical. Okay, if you look at the flute, if you look at this flute is looking to you this like, but someone is looking from this side, the flute is looking like a circle. From this side someone is looking from this side, it looks like a cylinder, right? So it is about the position. So nothing is constant. At the first state I say nothing is constant, everything is relative when it comes to the relativity, right? Especially when the object is moving in very much near to the speed of the light, then the relativity happens, the special theory of relativity happens at that time, right? So I try my best to understand you. Hope you can understand these kind of things. Still, if you have any doubt, I always tell that write me in the comment section. And the new thing is that you got the notes from the WhatsApp channel. I have made a WhatsApp channel and I will give you the link, and on that cases you will find all the notes, all the previous lectures notes you will find on that, right? So not to worry about that, these notes or dash notes, you just have to join the WhatsApp channel. I will provide that link in this description. Okay, so if you have any doubt, any kind of questions, ask me in the comment section. Please spread this video, please subscribe this channel, as the scientific mentality inside our society in the whole world. I am not telling about any kind of country, right? In all country you have to spread the scientific mentality, the scientific tempo. So we have to support these kind of channels. It is not about me, those who are making these kind of videos or making these kind of scenarios, you have to support that, otherwise these channels will be collapsed one day, right? So it is our all responsibility, right? We are going with that spirit. And I will tell why the name of my channel is Sudipta. I have described on the channel, because Sudipta meanings happenings a lot. It has two philosophical meaning, right? Su means good and Dipta means light, who spreads good light. And you are also, all you are also here to spread the good light everywhere, right? So this is your responsibility and this is our responsibility to grow this channel. At the end, I am conclude my video by saying thanks you for watching this video.